John Steckler is our next presenter. He comes to us from Archer Daniels Midland, or ADM as it's known, and he's the process automation manager for them. And I'd like to ask you to join me in welcoming John.
Well, good afternoon, and thank you for giving me the opportunity to share one of ADM's stories with you today. The agenda for my session is I really want to talk about ADM at a glance, just in case you don't know who we are. I want to talk to you a little bit about our values and our responsible growth initiatives. But my main focus today is really going to be about automation strategies, and really how those strategies are going to help us achieve our goals. Specifically, a 15 by 20 goal that we have in our 2011 Corporate Responsibility Initiative, which I'll talk about a little bit. And again, within plant automation and control, I really want to share some of the solutions and the results to date. So really, who is ADM? ADM was founded in 1902. We have our headquarters in Decatur, Illinois. Worldwide facilities are approximately 265 in approximately 75 countries. Net sales last year were $61 billion, and we have approximately 30,000 plus employees. So you can tell we're a very large company and very distributed. Our primary business segments include oilseed processing, corn processing, and agricultural services. We also have some other business segments, notably cocoa processing, which a lot of people don't know that we do, animal nutrition also, and wheat milling, for example. Simply put, we are food, feed, and fuel. So what is our vision? Within ADM, we call it the ADM way, and we really honestly want to be the most admired global agribusiness. To do that, we have to create value, we have to grow responsibly, and we really have to serve vital needs. So what are some of those vital needs? This was just a picture of our global distribution and some of our facilities worldwide. Here's a little typo here. By some research, the estimation is that the population will reach, I believe it's 8 billion, is that correct? 9 billion by the year 2050. To do that, we're also expected to require as much as twice the amount of food. And I think Dick already mentioned the energy produced would be approximately twice as much as well as today. To do that, though, we obviously have to grow, and we have to grow very quickly. But we have to do it in a responsible manner. That's really part of our initiative, and that's part of our 2011 Corporate Responsibility Report. This report is available on www.adm.com/responsibility, and it's obviously accessible to anyone that wants to read through it. But the report itself really documents many of ADM's most important achievements toward these goals, as well as some of the initiatives that I'm going to mention here today. Let me back up here. So what is this plan, this 15 by 20 plan? Essentially what the plan is ADM is aiming for a 15% efficiency improvement by 2020 on a per unit of production basis. The areas of energy and emissions, water, and waste will all be included in that calculation. So what's the challenge? What's the challenge from an automation standpoint? Well, if we have 265 plants worldwide, all of these facilities were at various levels of automation. We have organic plants that we built. We have numerous acquisitions. We have joint ventures. You know, this obviously has created a significant difference in our plants with respect to automation and control. So within automation, the automation group, for us to participate in this corporate responsibility and the 15 by 20 plan, we really need to develop some automation strategies. You know, we really need these strategies for consistent and timely deployment across the enterprise. So at a top level, We really need to develop a global automation strategy. We really need to establish the common goals for these facilities. A key to this is, of course, the improved operational awareness or operational effectiveness. We need better information for the decision makers. We need to institute behavioral change. We want operators to operate the plant to improve overall efficiency. We want to reduce energy uses. We want to maximize the use of the natural resources that we have. And that's a big change from the way of an operator just operating the plant and keeping the plant running. So how do we do that? So we really need to create a foundation for how we want to automate and control our processes. Then the what of, for example, these initiatives that I just mentioned, really requires us to do that with the process of this foundation. We obviously need consistent visualization of our HMI. We want to control our processes with either state-based control or S88 compliant batch controls. We really need to manage our alarms, we need to optimize our control loops, and we need to be able to do this to apply other tools, for example, with APC that's shown on the top. So part of this automation challenge, obviously, was to come up with an implemented approach to this. There was a development phase, and we obviously worked close with our DCS supplier, Novatech, to come up with this development. We also developed training. We had initial implementations, and then expanded rollout, and we'll cover that in more detail later. Within ADM, we really had a great opportunity over the last several years to apply this strategy with 7 major greenfield projects going on at the same time. Our initial project at a new greenfield plant in Clinton, Iowa, was where we initially implemented some of these strategies. Because we did that at that plant and got that plant started up before the others, we were able to apply this same strategy to all the other plants that we started up. You know, one of the things that sometimes when we were, before these plants were starting up, when we were told that we were going to build 7 plants at the same time, our tendency within ADM would have been, you know, this is going to be a firefight. We're really just going to do things exactly the same we used to do things. Well, the reality was that didn't make sense for us. We knew we needed to do things differently. So, you know, this was that opportunity, though, even though it was an implementation, it was done at a very large scale. One of the first steps, obviously, was you really can't control what you don't measure. We had an advantage within these projects that they were, for the most part, linked to the Corn Division. The Corn Division had an environmental reporting requirement a few years back, and because of that, we ended up agreeing to buy a PI as our data historian. Because we had that data historian in place for these greenfield projects, we obviously were already ahead of the game in terms of having a data historian in place. So we needed more data. The concept of using the steam usage and measuring that, of measuring coal and measuring gas, were really not new to us. But one of our biggest issues was with electrical side. You know, with current technology, especially with the use of IEDs, it made that very possible. The real challenge was not only the use of the IEDs, but how am I going to integrate all of that data up into our DCS system and then get it into the historian. That obviously was a big challenge, and we were very successful at that. You know, we needed to get electrical usage not only from the utility, through our switchyard, through our power distribution, so we could really make better business decisions about the information that we had in real time, and we needed to do it at a very granular level. But we also needed to understand our alarms. We need to understand our operator actions and what they were doing, and also look at our control loop performance. You know, all of these were about getting more data and then doing something with that data. You know, obviously we're able to generate reports and get more information and focus on our energy and water usage, again, as part of this presentation. But we're actually better now to correlate that information on a more granular fashion. You know, that was very critical because we really needed to structure for for how we would display our processes to the operators, so there's some correlation between this reported data and the process. This strategy really led us into the next concept, which is called state-based control, or what I would call unit operations. So how are we going to do this? We're going to develop a programming standard on how we actually automate and control our processes. We're either going to use state-based control, which is what we within ADM call flex-able, or we're going to use an S88 batch programming technique. What this allowed us to do is really focus on the plant as a collection of units from a programming standpoint, as well as visually to the operators. The intent was to create consistent, repeatable operations. It allows operators to focus on process improvements and efficiencies, and less on keeping the process running. It provides a framework for advanced process control integrations, and additionally provides a framework for advanced dashboards and KPIs at the unit level. This next slide is really is what we call a state transition diagram. It's part of the process of doing this state-based control. The nice thing about this is it not only helps the automation teams with the programming, but it's really an easy way for engineering, for operations and automation folks to really communicate about how they want their process to run and what they want it to do. This is really an example of a CIP sequence, and I think this is probably for maybe a heat exchanger. One of the nice advantages of automating that CIP sequence is you're able to reduce your water usage, reduce your chemical usage, and by optimizing that process, and you make it as efficient as possible. Because of the way we did our programming, when you apply that and you get your most efficient sequence out of that CIP, you apply it to all of your evaporators, or all of your heat exchangers. By doing that, that small gain that you achieved on one heat exchanger is now gained on every heat exchanger you have in the whole facility. So that small little bit that you thought you got on one is really multiplied by, who knows, 50 to 100 times. It's very powerful. Another thing with state-based controls, we really wanted to display the process in a very different way. We really wanted to build like a hierarchy for how the operators can not only visualize, but also operate the process. We still have the P&I drawings, the unit graphics are still available, and they'll complement this type of a unit display. So what's the advantage of state-based control? Well, obviously, with the programs doing all the work, like the continuous checks and the steady state checks, operators can really concentrate on operating at the unit level instead of the individual control loop level. The operators can also visualize and focus on process improvements and enhancement at the unit level. These improvements are really directly related to ADM's 15x20 initiative. Startup and shutdown sequences can be optimized and improved. And of course, that would increase your equipment availability and, in essence, reduce your energy usage. In some of our plants, we really couldn't do the state-based control. We really needed an S88 solution. In a lot of our fermentation processes in our cocoa plant, we really needed to empower our operations staff to make better decisions. We really needed a lot of flexibility with respect to the customer products and the product specs. We need faster, more efficient startups, obviously less reprocessing, and get the product in spec quicker. In reality, every one of those items is really about being more efficient with your energy and your water usage, and if you have less reprocessing, obviously there's a tremendous benefit and value there. So back to some of the building blocks I talked about earlier. We talked about the state-based control and a little bit about the S88. So what about alarm management? How in the world do you want to talk about alarm management and say that relates to energy? Well, really, it's really talking about we want to improve operator effectiveness. That's the key. We want to reduce nuisance alarms in a way that we can actually define alarms differently. Within ADM, within the corn division, we've defined 3 potential impact areas. We defined them as safety, environmental, and business. Within those 3 impact areas, we define 3 levels of severity. Those levels of severity are minor, major, and severe. I will note here that in the potential impact category of safety, there is no difference between minor, major, and severe. There's also no time to respond or consequence. The response time is immediate. So that one is a very special category, of course. So the concept is once we can manage alarms in this way, we're going to respond to alarms in a very different way as well. In terms of energy, for the most part, that's going to be a business impact, and the plants will be able to address that on their own terms in terms of what value it is for them in terms of energy. Obviously, on the environmental side, emissions is part of that, and it's very critical as well. So what are the steps in alarm management? What we're doing is we're following the 7-step process for effective alarm management and following ISA 18.2. The first step is to develop an alarm philosophy. We've done that in the Corn Division. We're currently in the alarm analysis phase and alarm reduction phase, and we're working towards the documentation and rationalization phase, where we'll actually allow the operators to find the alarm in these categories that I defined, the business, the safety, and the environmental. They'll be able to click on either the alarm screen or the graphic screen and be able to immediately see a display of what they need to do, how much time they have to respond, and what the consequences of that is. Another component of this building block is loop monitoring tuning. We really need to provide tools and methods to improve our loop tuning and our loop priority for the plant. Obviously, this does affect production, quality, and our efficiencies, and we're really intended to tune loops now for optimal efficiency, for maximum performance, and to maximize device longevity. And obviously, this has a great impact on our energy reduction initiatives as well. So having said all of that, those component building blocks really step us into a whole different game. But it's very important to note that within ADM, and especially for you if you're thinking about APC or if you're already doing it, we really wanted to make reasonable attempts to make sure that we've done everything that we can do on the process and automation side before we start applying APC. Because when we go to justify an APC project, we really want to know that we can apply the ROI on the APC solution itself and not on any of these other things that we might have done to make the improvements. We really want to base the improvement on the APC solution. In terms of the specifics, we've applied APC solutions on distillation columns. We've had significant reductions in the steam usage. I can tell you that the ROIs are probably in the range of 6 to 9 months for an APC project on a distillation column. We're currently working on improvements to our coal boiler efficiency. Part of that coal boiler efficiency is on an individual basis, but also on optimizing the individual boiler balances so that the most efficient boiler will operate at the highest efficiency, and then the other boilers will be staged accordingly. And part of that is also going to be to improve the emissions. You know, we'd have a lot of cogen facilities within ADM, and if you can just reduce your O2 a very, very small percentage, you're going to cut down your fan amps, you're going to cut down your energy usage, you're going to cut down your emissions, and it's going to have a very significant impact by applying this APC solution. If you talk to me in 6 months, I can probably tell you what that ROI is, but it's probably going to be less than 6 months. One of the other initiatives is after we do the coal boiler, we're going to talk about whether we can optimize our turbine generator sets as well at these cogen plants. Again, we want to minimize steam usage and maximize power generation. This is just a bit of a visualization of our APC advanced process control with some of our process control D3 graphics, and I really don't need to spend much time on that. So what's our current status? From the state-based control portion of things. We're really trying to continue and improve and refine that as we incorporate additional plants into that state-based control. They're really always coming up with additional ideas, and we really need to honor some of those great ideas and incorporate that into our standard. From a training standpoint, I was in Europe last summer and trained colleagues in Europe, and they've pretty much accepted that state-based control is going to be their de facto standard, and they've already moved forward with applying state-based control on most of the oilseeds plants in Europe. So they're moving very aggressively to migrate all of their existing code to state-based control. They've already seen that there's a significant benefit there. We also have rollouts ongoing, and we're really looking at opportunities where applying that strategy will have significant benefits, because we don't have opportunities to shut the plant down, so it does require a significant amount of effort. But where we have opportunities, we're taking advantage of that. Within the corn division, oilseeds division, we have ongoing projects continuously. And I also really want to note that we're also applying this strategy to a couple pilot plants that we're working on currently in our research department. So what are our real results? Without going into specific numbers and dollar amounts, we really have advanced our ability to measure and understand energy and water usage as it relates to operations. We're able to make better decisions related to energy usage and operational efficiency. We're more efficient. We have more efficient plant operations through improved automation programming. And I think the very critical component of this is we have more efficient operators and operations. Any new initiatives that happen to come about at ADM, we're really what we think that we've done is we've created the foundation within our automation to really be able to react to any new initiative that comes about, just because we've taken the time to build these and create these building blocks. And thank you for your attention, and that's really all I have today.